This is the first section of 4.5, the remainder factor theorem. So we're going to start with the remainder theorem. And the remainder theorem says, if f of x is divided by x minus c, then the remainder is the f of c. So, for example, what's this look like? I'm going to give you this function, x cubed minus 2x squared plus x minus 1. And I want to find the remainder given the binomial x plus 2. Okay, so we're going to do it the long way to start, and that is we're going to find the remainder using long division. After you've done the long division, you should have gotten that the remainder was negative 19. So what does this mean? First of all, I don't want to long divide. Long division is definitely not the best way to go. If it can be avoided, I always avoid it. If I'm given x plus 2, this means that c is negative 2. If I'm given x plus 2, c is negative 2. Remember, this is x minus c. What are you subtracting to get positive 2? You're subtracting negative 2. So let's use the remainder theorem. And the remainder theorem says that the f of negative 2 should be our remainder, negative 19. All right, let's take a look. So when you plug in negative 2, you get negative 2 cubed minus 2 times negative 2 squared plus negative 2 minus 1. So that's going to be negative 8 minus 8 minus 2 minus 1, which is indeed negative 19. So you don't need to long divide anymore if you're given a binomial. You also might remember there are shortcuts using synthetic division, sometimes called synthetic substitution. C is negative 2. My coefficients on the function are 1, negative 2, 1, and negative 1. Bring down the 1. 1 times negative 2 is negative 2. That gives you negative 4. Negative 4 times negative 2 is 8. That gives you 9. 9 times negative 2 is negative 18. There's your remainder. And that matches, and that matches. So that's the remainder theorem. Well, why does the remainder theorem matter? It's going to help us find factors, and it's going to help us find zeros. So next we're going to look at the factor theorem. So you have this x minus c. It's a factor of the function if and only if the f of c is 0. Well, what does the f of c represent? That represents the remainder, which we just did in the previous problem, was negative 19. IFF, if and only if. So I'm going to give you a function, and I want to know, is x plus 2 a factor? Okay. I am not going to use straight plugin. I always use synthetic when possible. So I have negative 2. I'm using what number plus 2 is 0? Negative 2. Always comes down to zeros. 3, 5, negative 6, negative 8. Do the synthetic division, synthetic substitution. When you do the synthetic substitution, you get that the remainder is 0. So this means that x plus 2 is a factor and x equals negative 2 is a 0. Okay. What happens if I ask you to find the zeros? We just found one. It was -2, but I gave you a starting point. I gave you a factor to begin with. What if I don't give you anything to start with? Okay, so if you're given that x equals -1 is a 0, the f of -1 is 0. Is that what we just did right here? The f of -2 was 0. And x plus 1 is a factor. So I'm just like, there's several ways that you can write it. You can write that the value of the function is 0. You can actually say x equals that value is 0, and you can write it as a factor. Okay, there's a lot of information. So what happens when you don't have any zeros or factors to start with? So the number of real zeros is at most equal to the degree. All right, P over Q. That's a Q. I like making fancy Qs. P is the constant, Q is the lead coefficient, and this tells you the potential rational zeros. Rational. Square root of 2 is not a rational number. You do not get rational solutions using the quadratic formula unless the discriminant is a perfect square. So the factors of P over the factors of Q, hopefully you remember this from last year, tells you the potential rational zeros. So let's look at this same function that we just used. The f of x is equal to 3x cubed plus 5x squared minus 6x minus 8. And I want to know the potential rational zeros. This is going to be, my constant is 8. We don't need to worry about the negative because it comes out in the plus or minus. So the factors of 8. So it's going to be plus or minus. The factors of P. P is the constant of 8 over the factors of the lead coefficient, and the lead coefficient is 3. The factors of 8, 1, 2, 4, 8. The factors of 3, 1 and 3. You don't need to write the plus or minus every single time. Your book does. I don't require that. Just write the plus or minus once. You do need to spread this out. So you have 1 over 1, 2 over 1, 4 over 1, 8 over 1. The order in which you write them does not matter. Plus or minus, let's see, 1 over 3, 2 over 3, 4 over 3, and 8 over 3. Notice that -2 was a 0. So x plus 2 was a factor, but -2 is on this list. I didn't write plus or minus every time. You don't have to. So if there are real rational zeros, this is where they come from. Okay, well, doing all that plugging in, and how do you know which ones work? So there is a special guy named Descartes. He is French. It's not Descartes, it's Descartes. All right, Descartes' rule of signs. This is a little bit gnarly, and I will certainly go through it. The number of positive real zeros, they could be rational or irrational. Rational root theorem, the P over Q is only for rational. Descartes is for rational or irrational, is equal to the number of sign variations in the function less an even integer. the number of negative real zeros is equal to the number of sign variations in f of negative x less an even integer. Okay, so what does this mean? Sorry about this. I changed my mind in the example I wanted to do. Here's x to the fourth minus x cubed minus 6x squared plus 4x plus 8. I want to know how many potential real zeros. I want to know how many potential real rational, and I want to know how many potential positive and negative. And this is really going to help us when we do all of that plugging in with P over Q. Okay, first, there are at most 4 real. That's from the degree. Okay, now we're going to look at this sign change business. Positive x to the fourth. Positive to negative, that's one sign change. So that's one sign change. Negative to negative, that's not a sign change. Negative to positive, that's a second sign change. Positive to positive is not a sign change. So for the positive real zeros, oops. The positive real zeros, there are either 2. So here's where this less and even integer comes. Okay, even integer, 2, 4, 6, 8, 10, 12, etc. So I'm going to subtract 2. So I got that because less and even integer is essentially meaning subtract 2, subtract 2, subtract 2 until you get to 0, because there can't be a negative number of zeros. So this means that there are either 2 or none. Let's look at the negative real zeros. Okay, the negative real zeros. Plug in negative x. When you plug in negative x, you get x to the fourth plus x cubed minus 6x squared minus 4x plus 8. I just plugged in negative x. Negative x quantity to the fourth is positive x to the fourth. Minus negative x cubed is negative x cubed times negative 1 is positive x. We start with positive x to the fourth. Positive x to the fourth to positive x cubed, not a sign change. Positive to negative, one sign change. Negative to negative, no sign change. Negative, positive, another sign change. So there are 2, or subtract 2, you get 0. If there is one sign change, then there are at most 1 positive real zero. If there's one sign change in the negative, then there's at most 1 negative real zeros. You can't have, when you subtract 1, so let's say your sign change, whether you're doing positive or negative, if there's 1 sign change, that means that there is at most 1 0 of that nature. Because when you subtract 2, you get a negative. All right, so I know that there are at most 4 real zeros. And of those real zeros, there are either 2 or no positives. There are either 2 or no negatives. What about the rational? Okay, the potential rational come from P over Q. All right, so P over Q, that are the factors of 8. 1, 2, 4, 8. The constant is 8 over the factors of the lead coefficient. The lead coefficient is 1. So here are my potential rational zeros. Okay, and we said that positive real zeros, 2 or none, negative 2 or none. All right, so now we're going to use the remainder and factor theorem. So the remainder and factor theorem says that if you plug in the value of C, plus or minus 1, 2, 4, 8, and you get 0, then it's a factor of the function. So start by plugging in 1, plug in negative 1. 1 didn't work, but when I plugged in negative 1, I got a remainder of 0. So this means that x equals negative 1 is a 0. It means that x plus 1 is a factor. Here's what else it means. X equals negative 1 is negative. X equals negative 1 is negative. Well, in the beginning, we said that the negative real zeros, there had to be 2 or none. Okay, well, we just found one of them, which means there must be another negative solution. If there's one solution, we said, well, there are either none or 2, that means there must be one more. Use the reduced function. Use the reduced function, which is x cubed minus 2x squared minus 4x plus 8, and synthetic divide from here. If 1 didn't work the first time around, it's not going to work the second time around. Find what else works. Find another 0. Since I knew that there had to be another negative solution, I went straight to negative 2. So this means that x equals negative 2 is a 0. X plus 2 is a factor, and there can be no more negative real solutions. You have a quadratic. X squared minus 4x plus 4. This factors as x minus 2 quantity squared. So the remaining zeros, you get x equals 2 with a multiplicity of 2. The factor is x minus 2 squared. Okay, so all together, the zeros are x equals negative 1, negative 2, and 2 with a multiplicity of 2. In factored form, this is the f of x equals x plus 1, x plus 2, x minus 2 squared. Okay, I want to go back for a second though. Your factoring skills, if your factoring skills are good, which I hope they are, I want to go back to here. There is no more synthetic division necessary. There's no more P over Q necessary. X cubed, after you found the first 0, minus 2x squared. After you found the first 0, this factors by grouping. And I'll tell you what, in the homework, or just in general in the book, your book uses a lot of grouping. Group the first 2 terms. Group the second 2 terms. Find the GCF. The GCF of x cubed minus 2x squared is x squared. That leaves you with x minus 2. The GCF of negative 4x plus 8 is negative 4. That leaves you with x minus 2. They must match. After you take out the GCF, what's left, in this case x minus 2's, they must match. So now when you look at this function, what's the GCF? The GCF is x minus 2. The GCF is x minus 2. So when that's gone, you're left with x squared minus 4. Which factors difference of two squares, x plus 2, x minus 2. Which you'll notice is exactly what we got. X minus 2 quantity squared times x plus 2. X minus 2 quantity squared times x plus 2. So your ability to group is going to save you a lot of time. Okay, I want to look at one more. So if you don't need another example, clearly you can stop along the way. I want to do one more because Descartes is can be pretty confusing. All right, so let's look at the f of x equals 3x to the 4th plus 4x cubed plus 7x squared plus 8x plus 2. We have at most 4 real answers. At most, there are 4 real answers. Let's look at our Descartes. This is so helpful. There are no sign changes. Positive 3, positive 4, positive 7, positive 8, positive 2. This has no positive real solutions. That's going to save you so much time with P over Q. Let's look at the f of negative x. That's going to be 3x to the 4th minus 4x cubed plus 7x squared minus 8x plus 2. Plug in negative x, pause the video if you need to. This has from positive 3 to negative 4, that's 1 sign change. Negative 4 to 7, that's 2 sign changes. 7 to negative 8, that's 3 sign changes. Negative 8 to 2, that's 4 sign changes. Yeah. Therefore, there are 4, subtract 2, you get 2, subtract 2, you get 0. There are either 4 positive real zeros, 2 positive real zeros, or no positive real zeros. No, negative. I misspoke. I plugged in negative x. This is for the negative reals. Okay, now let's look at of these potential negative real solutions, let's see where the rational ones will come from. So P over Q plus or minus factors of 2, 1, 2, over the factors of 3. Do you still need to list the plus or minus, even though we know there are no positives? Yeah. If I ask you, when I ask you, what are the potential rational zeros? You need to list them all out. So that would be 1, 2, 1/3, 2/3. Now, when I plug in, I know it can't be positive 1 or positive 2 or positive 1/3 or positive 2/3 because Descartes' rule of signs says no sign changes, no positive reals. So what am I going to do? I'm going to plug in -1, etc., and find out what works. I started with -1, and luckily -1 worked. So this means that x equals -1 is a 0. X plus 1 is a factor. That leaves me with 3x cubed plus x squared plus 6x plus 2. I have one negative solution. That means that there has to be at least one more, because having one solution isn't a viable option. I have to have two now. Now that I found one negative, there has to be another negative. So synthetic divide again. Synthetic divide again, and -1/3 worked. So you get down to here, and you get x equals -1/3 is a 0. Here's the issue. We never factor with fractions, and your book gives fraction factor answers, and those are not acceptable. No, this is, you're going to write that x plus 1/3 is a factor. No way. No way. This is going to be 3x plus 1 is the factor. If x equals -1/3 is a 0, multiply both sides by 3. That's where I got the 3x, and add 1. However, you should have grouped. This is not necessary. It's okay, but when you don't have a lot of time on the quiz or the test, you should have grouped it. Gives you x squared, 3x plus 1, plus 2, 3x plus 1, x squared plus 2. There's that 3x plus 1. There's that 3x plus 1 factor. So you have factors, x squared plus 2, that's imaginary answers. X squared plus 2 is imaginary. The factors are x squared plus 2, 3x plus 1, x plus 1 from up here. The zeros. Okay, the zeros. We already knew about -1 and -1/3. X squared plus 2 equals 0. X squared equals -2. X equals plus or minus I√2. Square both sides, you get the square root of -2. I comes out, the root stays in. Notice 2 negative answers, 2 negative real answers, no positive real answers. There you go.